Today's video is part 2 of section 5.7, inverse trig functions by integration instead of differentiation, and we're going to learn a new technique, completing the square. Your homework from 5.7 is 31 through 41 odd, 47 through 50 all, but on number 49 do not do B and C. So on my inverse trig, my arc sine, arc tangent, arc cosine, etc., we're going to need another technique in order to do those, completing the square. And you will see that in these two examples. So in this first example, I'm not doing your homework problems, I'm doing evens around them, number 32. In fact, I'm going to do the first two. So this is a definite integral because it has an upper and lower bounds, and it's 1 over a quadratic. And if I think about u substitution, and when I take the derivative of the u substitution, it would give me an x to the first power. Well, I don't have an x to the first power to get rid of. And this is not an inverse trig function, but if I complete the square, I can turn it into one. So to remember how to complete the square, I take the first two terms, I put in parentheses, and I scoot out the third term. And I'm going to complete the square inside the parentheses. And so I take b divided by 2, which is 2, and square it, that is 4. So since I added 4, I must also take away 4. And then I'm going to go back and write it with my integrand. So now this is x plus 2 quantity squared plus 9. Well, that looks like your inverse tangent, your arc tangent. So let my u be x plus 2 du dx. And so again, if you look at this, it's 1 over a. My a is 3. Arc tangent of whatever the what's inside the parentheses, whatever your u is, which is x plus 2 over your a, and it is a definite integral, so from 2 to negative 2. So I put in 2 plus 2 here is 4. I put 1 there on the outside. I put in negative 2, which happens to be 0. I took a look at my unit circle. Tangent happens to be sine over cosine, right? And so that's 0 over 1, which is just 0. I'm sorry. It's what angle, this is an inverse trig, sorry. What angle produces a ratio of 0? Well, the angle of 0 produces the ratio 0 over to 1 or 0. So this all goes to 0. And so we can leave it as 1/3 arc tangent of 4 over 3. So again, I'm more concerned about the technique at the beginning. I cannot integrate this. If I complete the square, I can make an arctan. There is a second thing with completing the square. So this one here. Now, if I take the whole denominator and I set it equal to u and I differentiate it, I will get a 2x. Watch. I don't have to complete the square. I don't have to try to make it into one of the inverse trig functions. Just use u substitution. The problem is I have 2x plus 2. I have 2x minus 5. But I can force it. So if this was the u substitution, this would go away, right? Well, I want 2x minus 5. So if I do 2x plus 2 over this denominator minus, I could put 7 over this. I went ahead and put the 7 out. But minus 7, would that give me my 2x minus 5? I went ahead and extracted out the 7. Now, I already know what I'm going to do here. But let's take a look at what I'm going to do here. Now I'm with the same thing that I had with 32. Look at this. If I take a u substitution, I'm going to get a 2x. There isn't any 2x. I have a 1. I mean, I did have a 7, but I went ahead and I GCF'd that out. So why not complete the square? So I'm going to take the b term 2, divide it in half, that's 1, square it, that is 1. Since I added 1, I must subtract 1. So that's going to be x plus 1 quantity squared plus 1. So now I'm going to go ahead and put this back together. Scoot this up a little bit. So I still have this, minus, now I went ahead and I substituted with the complete the square. Let my u for this part be x plus 1 du dx. And we already know what this is, right? I did that up on top. So that's 1 over u, because when I do the u substitution of this, I get this. Now let's go ahead and continue. So this is the natural log. I substitute that back in, x squared plus 2x plus 2 minus 7. And this is an arctan, right? So it'd be 1 over 1, because a is 1. And the tangent of the u, which is x plus 1, over my a, which is 1. I don't need to write that, plus c. Done. So those are the two main techniques for this section. Thank you.